Okay, so let's get started. Next, we'll talk about an open source tech stack to analyze or review internet. We have here Steffen Wenz, who's a CTO at TrustYou. He will be sharing the lessons they are learning, building an open source tech stack to crawl, store, and analyze all of the hotel reviews in the world.
Thank you. Hear me? Thanks so much for coming to my talk, especially for the people standing. I hope you're comfortable back there and can hear me fine. My name is Steffen. I work for a company called TrustYou. We're based out of Munich, Germany, but we have a development office here in Cluj with nearly 40 people now. I won't bore you too much, but I will say some words about what TrustYou does, because my topic is obviously related to that. What TrustYou is really good at is crawling and collecting hotel reviews and making a summary of them that is useful to other people, guests looking for hoteliers analyzing their own hotel. And this is what the TrustYou algorithms have to say, among other things, about the hotel I'm currently staying in, the Ramadan Cluj, that the conference organizers were nice enough to put me in. It's near the city center, which is true. Things in Cluj are usually in walking distance of the city center, I found. It's got clean rooms. And there's a French quote just to show you that we analyze international text as well. We do more than 20 languages natively. And it's popular with solo travelers. Perfect. I'm a solo traveler on this trip. We did have a warning in our summary that the remote or the TVs didn't work for a lot of people. But I tested that last night and it's working fine. So we make this summary for more than 500,000 hotels in the world. And we want to make them available to travelers so they can pick a nice hotel for their stay. And the way we make them available is by selling them to websites where people book hotels. One of them is Google. Google is a client of ours. They take the summary that you've seen in the previous slide, modify it a bit, and show it this way. This is a different hotel in Cluj. Show it this way in their maps and search applications. We don't just have Google as clients, we have hotels.com, Kayak, Trivago, to name some of the big ones, and many, many others that show our data. So we care about collecting textual content from the internet scale. We care about analyzing it, aggregating it. And this is a very, very rough overview of the architecture that we have in place. My goal for the talk today is to tell you about some of the technologies that we're using, so that when you ever come across having to solve a problem similar to ours, remember these technologies, you somehow find my slides from this talk, and you end up using these frameworks that I'm presenting to you today. TrustYou loves Python. We're a company that's all about data processing, and I think Python is the perfect language choice for that. Would you raise your hand if you've worked with Python in your private life or professional life? There you go. Sorry for asking a question about your private life. Would you raise your hand if you didn't just raise it, but would consider learning Python if interesting enough opportunity presented itself? Very good. So everyone who just raised their hand can talk to me afterwards. Let's start in the beginning. Crawling. Sometimes you think you're onto something really interesting and you just need data to play with. And getting it can be a pain in the ass. Thankfully, there's Scrapey. It's a crawling framework for Python that makes extracting data massively from websites really easy. I, for example, have crawled a list of all the hotels that are available on Booking.com along with address details, etc. with a Python script of maybe 20 or 30 lines. Really cool. Crawling isn't all that complicated, but once you try to implement a crawling framework yourself, you stumble across all kinds of annoying things that you have to take care of. There's the so-called tag soup. I don't know if you're familiar with that term, but it basically refers to the fact that many websites don't have valid XML. It's hard to parse. And browsers have an insane amount of heuristics that try to fix the broken HTML to show you something useful. And when you crawl, kind of have to use some similar heuristics to parse the website. And then, you you're going to have to queue millions of requests. You want to run them in parallel to move them quickly. And you want to throttle. Sometimes they block you if you call too much. You don't have to take care of that. Scrapey does all of that for you. Of course, you need to configure it. And if you find yourself having to extract some data this way, I encourage you to check out this code sample that I've put up on our GitHub account. So assume that you get hotel reviews this way. What do you do with them? You want to analyze the text, their textual data. I'm going to run through this pretty quickly since I have limited time, but I'm happy to answer questions about these frameworks in more detail afterwards. Basically, when you're treating text, there's just two different schools of thought on how to extract insights from it. There's linguists that think that all the different ways that text can be generated by the human brain or by a valid grammar language can be enumerated, can be written down in the form of rules. And then these rules can be used to detect valid text out of hotel reviews. It's an old school of thought, it's quite an old discipline, and it's still around, and this school of thought is quite present at TrustYou. I can tell you more about that afterwards. If you want to do that kind of thing in Python, you should check out this book, which basically is a very long NLTK tutorial. NLTK is the Natural Language Toolkit. I think the TK is for toolkit, it's kind of stupid. Which helps you with all these typical linguistic treatment of text. It starts with having to break down text into words, break it down into sentences, then there's part of speech tagging. This is basically about recognizing nouns, verbs, adjectives in text, and then parsing, which I mentioned briefly as I started this slide, is about determining which kind of production rules from grammar generated a certain text. That's one school of thought, and it gets you some part of the way. However, there's also the statistical approach to dealing with natural language, and that one arguably is winning now. If you were in the introductory panel this morning, there's machine learning, deep learning that is state of the art in recognizing human speech. If you speak with your Siri or your Google Voice, you're talking to a neural net that is smart enough to figure out what you're saying better than a linguist could ever code all the rules in the world to understand you. So many, if not all, linguistic problems can be modeled with machine learning problems. At TrustYou, for example, we look at a sentence in a hotel review and we need to know, well, is that a positive or a negative opinion? If you're a linguist and you hard code some rules, you can probably get it right 80 or 90% of the time. But if people say stuff like, the air conditioning was so strong that in summer we were all freezing in the room, that's an actual quote from a review that I'm citing. It's kind of hard to tell if that's positive or negative. It's actually more on the negative side. Machines are better at just learning those kinds of ambiguities given enough data. These kinds of algorithms are right at home in Python. Python is a language very popular with scientists and with great support for scientific computation. You have the NumPy, SciPy, Pandas frameworks, which help you dealing with vectors, time series, data frames. And building on those are machine learning libraries such as scikit-learn. That's one that's actually used in production at TrustYou. And then TensorFlow, a brand new library. I haven't used it, but I put it on the slide. It's cool. It's a deep learning framework published by Google just last year. Worth a try. I only have 20 minutes today, but I did want to show one cool thing at least I should do. Who here has heard of Word2Vec? A couple of people, perfect. Let's see if I can explain it right. So Word2Vec is kind of a trendy topic in natural language processing in recent years. The base idea is that you want to associate words with a vector in some kind of space, and you want to build that association in a way that in that space, proximity of vectors, direction of vectors, correlate somehow with meaning that humans would assign to that word. Sounds really complex, but there's a very simple base idea behind all this word-to-vec, which is that words that occur in similar contexts in text, and context being the words that occur immediately around it. Words that exist in similar contexts in text tend to mean the same thing or similar things, are related in semantics. Just like, well, I'm trying to think of an example now, but I'm drawing a blank. Anyways, let's look at the examples I have on this slide. This is actually from crawling a list of all the meetups that exist in the world, something that I did earlier this year. Meetup.com, I'm sure you know about that site. There's many great meetups right here in Cluj. Those were in the data set. Training a word-to-vec model on all the meetup descriptions in the world. You're able to use the Python library called Jensen, also in production use at TrustYou, to ask it questions like, what are the 3 most similar words to the word Python? And it'll tell you JavaScript, PHP, sorry about that one, and Django. And you can ask it from the 3 Python, C++, and JavaScript, which one doesn't match? And it will tell you C++. You can find an argument why that's true. But of course, Meetup doesn't just talk about programming languages. There's all kinds of meetups on there. There's cities being quite present. So if you ask it about Berlin, it'll tell you some other cities in Holland, unfortunately. And the last one is kind of funny. If you ask it about ladies, it'll tell you girls, mamas, and gals. These kinds of meetup groups are quite frequent on meetup.com. The Cluj Mamas group, I don't know if that exists. So this is just some fun with word2vec that goes to show you that just from looking at a bunch of text, unsupervised, these kinds of models can discover interesting semantic relationships between words. And word2vec is just one possible thing there, but that's what the field said, statistics, machine learning. So assume you found a framework to analyze your text. Oh my, I'm running low on time. If you're doing analysis at web scale, you're going to want to use big data technology. I could fill an entire afternoon talking about big data, but I always like to see all these technologies that keep springing up in kind of a historical context. And you can't see it, but there's supposed to be a Google logo right there. So this is like time, the last 10 years, and kind of the interplay between what Google keeps inventing and publishing and what gets open sourced by the Apache Software Foundation. And obviously there's other players, but Google is a quite prevalent one in the open source field. It all started with, in 2004, when Google published papers on MapReduce and the Google distributed file system, which caused quite a stir and obviously led to the open source implementation of Apache Hadoop. Last year, in 2015, Urs Hölz, the VP of infrastructure at Google, was quoted saying, "We don't really use MapReduce anymore." So, as a company, TrustYou is a company that has most of their code base on MapReduce. My advice would be to you, if you haven't gotten in the big data field yet, to skip it and go to something cool and new like Spark. It's becoming quite clear now that the MapReduce paradigm is just a stepping stone on the way to more general purpose distributed computing frameworks. My theory is that all of this talk about when to schedule what, which resources, is just a traditional phase onto the commoditization of big data computation. It's already available today. You can go to the Google Cloud Data Flow, I believe. It's kind of Google Cloud Data Flow platform, which is kind of the latest trend in terms of big data technologies, which is just a platform that tries to abstract any kind of processing model, batch, real-time, streaming, and kind of provide a uniform layer for that, similar to what Yarn does, which is for resource management. And Google Cloud Data Flow has become available as an Apache thing called Apache Beam. It's currently an incubating project. I think that's going to be a technology to watch going forward. So anyways, core thing to take away from here is that there's many amazing open source technologies Many of them, unfortunately, I believe will become irrelevant in quite a few years, so don't get too invested in any particular one of them. If you do want to learn something, learn Spark. TrustYou is right now, I would say, transitioning to Spark. The cool thing about Spark is that, well, many things, but the base idea is that you write a so-called driver program that that describes more or less how you plan to modify your data. You say, load this data, join it with this other data set like so, filter it like so, transform it like so. And this driver program is interpreted on one machine, but execution of the different steps are scheduled transparently to you in a computing cluster. That's really nice, and I think that's the future of this paradigm. If you've ever worked with MapReduce quite noticeably was very much about, you write a piece of code, and this piece of code was distributed to 100 machines and run there. It still allowed you to do many things, but you had to be quite conscious that that's actually how it worked. Zipped up your code and ran it on a bunch of different machines. This one is a high-level abstraction, much nicer to work with. MapReduce is basically contained within Spark as two of the computation principles that they have. So Spark is MapReduce and much more. Full in Spark. Spark is being worked on, and many components are being added to Spark to make it even more useful. There's Spark MLlib, which contains scalable versions of machine learning algorithms. Machine learning is still a computationally expensive problem. Lots of data to train on. Means you probably want to run it in a cluster, and this library has a growing number of algorithms you can run in a scalable way like that. Even more interestingly, Spark Streaming, which was added on to Spark later on, but it still fits quite nicely within the overall framework. Spark by itself is a batch-oriented computation framework, much like MapReduce, but its scheduling and data processing are so fast because it's basically much less overhead to starting a batch execution than to a MapReduce job, that they were able to implement Spark Streaming on top of this framework by scheduling processing for so-called mini batches. Spark does streaming too. That's nice. All right. To conclude my talk, there's one little piece of technology that, one problem that often gets overlooked in these talks, which is, okay, what if I need to do everything that you've just told me, the crawling, the processing of data, the training of classifiers, the application of those classifiers. What if I need to do that more regularly, like every day? And what if I want to react to errors in that pipeline and rerun things if they failed? Workflow management. This usually you need it once you want to build a productive product. Just to name one example here, TrustYou uses a library called Luigi, done by people at Spotify. And all that it does is you're able to define a pipeline of jobs that need to run in some order. And just like with, let's say with the make file, you would start from the back. You would say, I want to analyze all the reviews, all the descriptions from meetup.com and build a word to back model from it. And to do that, I need to have crawled all the reviews from meetup.com. And then there's another task that is crawl all the descriptions from meetup.com. This Luigi scheduling algorithm figures out in which order you need to run these tasks. In this case, it's not very complicated, but at TrustYou, we have very, very complex dependency graphs between these things. And the nice thing is, if some part of this pipe fails, it will first try it again for you, because many times these things fail due to some network weirdness. We're talking about distributed computing here. Things go wrong sometimes. And even if it doesn't, the Luigi execution will crash, and you can go in and fix your code, and it will just resume where it left off. Any task that was already done won't have to be repeated. So just remember that this kind of solution exists, and if you find yourself, maintaining a huge bash script and then commenting out the first 3 lines when you need to rerun it. We did that for a very long time at TrustYou. Remember that there's better. Luigi's is a very small framework. There's many bigger solutions to this. Uzi from Apache is one example. All right, and with that, just once more a link to the GitHub repository where you can see example code showcasing everything except Spark. For those of you interested in learning Spark, there's a workshop today, so we're attending that. And it seems like I'm finishing right on time. Thanks for your attention.
Okay, now, if you have any questions, please just raise your hand and we will just hand you over a microphone.
Hi. Are there any potential legal issues when running web crawlers?
Very good question. For sure, making an HTTP request and storing the data locally and not doing anything specific with it, that's going to be okay. More often you're going to run into technical issues. There's many websites that have crawling detection going on. They will block you out if they detect that you're crawling, and you kind of have to simulate the behavior of a human to surpass those. What TrustYou has to deal with is we're actually aggregating all this content and reselling it as a product. And there, obviously, we have to make sure that we're always citing the sources that we're getting the content from, and that what we're creating adds enough value on top of what we crawl. The summaries add enough value on top of what we crawl to be considered their own thing in terms of copyright. One more?
Okay, then. Okay, there are no more questions. Thank you.
Thank you.